All right, everyone, I think we will go ahead and get started. We were told that a few students may not make it, but that's okay. We have a representative from each group. Just to let you all know that the students had a little bit different of a project, which we'll explain this year, but some of them were in finals week this week or on vacation for holidays or had previous commitments. But I want to welcome everyone to the Student Showcase. I have with me Amy Barfield and Gregory Hoffman. I am Grace Crane. We were the three GIO staff and mentors for the students this year as we moved along in a little bit of a different way than the students have done their presentations in the past. So we're going to give a brief introduction to the student projects this year. And then, of course, what you're all waiting for are the student presentations. So this year, like in previous years, we had the student winners of the IVSS projects. So this year we had over 220 projects from all 6 globe regions come in from the IVSS. And 22 students were selected from the 74 highest scoring IVSS projects to come to the annual meeting. They received an invitation and a stipend for their classroom of $2,100 USD. And all of these amazing projects can be seen on the annual meeting virtual platform, as well as on our globe.gov website. So I really encourage you all to go read their projects, watch their videos, look at their posters. They did an amazing job. But instead of presenting their IVSS projects this year, we wanted to kind of change things up and challenge these students a bit. So we decided to have a 5-week intensive data collection time where the students worked with Amy, Greg, and I on collecting data and meeting virtually over the past 5 weeks leading up to the annual meeting. So the overview of their project and the focus of their project was to connect the theme of the annual meeting, communicating globe and changing times, and involve at least one globe protocol or archived globe data, try to connect at least 2 globe spheres, and of course, include a research question methodology and an analysis and a conclusion. So they really tried to follow the scientific steps, as you can see here in this illustration, and work together across their groups. So some of their learning objectives were, of course, to investigate an environmental question using the globe protocols, communicate this research investigation and data analysis to all of you at the annual meeting, which is what they're doing here today. And then, of course, engage with one another. So we had students, instead of them working in their IVSS project group, we had the students work with other students across the 6 globe regions. So all of them got to work with someone else from a different region and a different country. And then something also unique about the projects this year is that we invited GISN volunteers, so that's the Globe International STEM Network, a few of those members who are professional scientists to come in and provide feedback and guidance to all of these students along the way. So we met weekly, starting about 5 weeks ago via Zoom, and all of the students were very enthusiastic. I was very proud of them. I know we all were. And we met each week and talked about our projects. We also talked about STEM careers and really just had time to work with one another on our presentations. And we utilized Padlet to really organize all of our data and our hypotheses and our questions, along with organizing our presentations. So it was really fun to work across all these student groups. So that is really the main overview. So before we dive into the presentations of the students, we have a special message from Jake Kay, who's the Associate Director for Research and Analysis in the NASA Earth Science Division. So this is all for the students and then also for all of you. And the students didn't know about this. So I hope y'all enjoy this special message from Jake.
Hello, my name is Jack Kay, and I serve as the Associate Director for Research and Analysis in NASA's Earth Science Division. My role is to oversee NASA investments in earth science research activities, covering everything from the center of the Earth to the stratopause and a piece of the sun. One of the key reasons I'm here to welcome you is because of the importance that we place in research, and especially in student research, is an important way for people to both learn about the Earth, but also to learn about the way people do science and the importance of working together, learning, sharing, and communicating what we do. NASA is proud to be a long-term supporter of the GLOW program since its inception. I'm proud of the accomplishments of the program and each of you who contribute to it. Together with our interagency partners at NOAA, the National Science Foundation, and the Department of State, we really
almost 15 minutes, took over 15 minutes.
Of you in the US and all around the world in the research that you do, the observations that you make, and putting them together to both learn about the Earth and to get experience in doing science that we hope will serve you well in the future. We see the student research as an important part of the GLOW program, and really look forward to hearing more about things. And I'm a big supporter of student research. I remember research I did as an undergraduate in college, and the more of you who do that, I think you'll benefit from the experience, and we should benefit from the things that you learn. At NASA, we see bringing new observational capability to the nation and the world is an important part of what we do. Just last week, we launched an instrument called EMIT to the International Space Station. EMIT stands for Earth Surface Mineral Dust Source Investigation, to study mineral desert dust and really learn new things about that climatically important forcing agent. So I hope you have a great meeting. I'm sorry I can't be with you. I will be flying back at the time of this, and if things go well, I'll be able to watch some of this virtually. But again, have a great meeting. Welcome, and thanks for what you do.
So thank you so much to Jack. I apologize. I said Jake. I apologize for that. For Jack K, and that message to the students. So good luck to the students. Now it is time for your amazing student projects, and we are going to start with project student group 1. So I'm going to pass it off to Amy so she can introduce her team.
Hi, everyone. My name is Amy Barfield. I work at the Global Implementation Office in Boulder. I've had the pleasure of working with student group 1 over the past few weeks. And I'm going to share my screen. Hopefully you don't see how many tabs I have open. And then I'm going to call forward our amazing students. We've got, I think we have Yasmina and Soraya here, and I apologize if Pacharpoon and Jimena are here as well. Please get ready to present. But just a couple of really quick words. I did put my name in here, but really I was not a contributing member. All the work was done by our amazing students, particularly Jimena, Yasmina, and Soraya. Unfortunately, I think Pacharpoon had was able to attend some of our meetings. It was a really pleasure getting to know her, but she was not able to collect data with us. So I'm going to pass it off to our amazing students. And go ahead and take it away. And just when you want me to move the slide, just say next slide, and I'll move forward.
Okay, thank you, Amy. So here's our presentation where we focused on analyzing soil characteristics and the correlation between climate and bioindicators in different regions. Basically, our project was revolved around the pedosphere. So we analyzed soil and yeah. So next slide, please. So here's our introduction slide. As Amy said before, Pacharpoon wasn't able to attend all the meetings, but she was from Thailand. Jimena also isn't at this meeting because she's actually doing finals right now, but she participated a lot, and she is from Colombia. Then I have Soraya with me. who's from Kenya. I'm Yasmina, and I'm from Michigan. And yeah, so next slide, please. So here are our research questions. The main questions we basically focused on were, number one, how do the soil characteristics and quality differ from each sample? We focused on like 2 different types because since Soraya is from Kenya and then me and Jimena, we both took our data from the United States, which is more of an urban area, and then Soraya had more of a rural area. So we wanted to see how those different regions would differ in quality of soil, and we wanted to compare them. And then number 2 also goes along with that one, which is how is the land cover different in each of the 4 study sites, which we originally had, but then had to cut that down to 3 study sites. And then our last research question was, how can the presence of trees affect the soil's quality and characteristics? Next slide, please. So these were our hypotheses to our research questions. Number 1, the soil quality from a rural region will be more fertile compared to soil from an urban area due to the greater amount of biodiversity. We went into this project knowing that Soraya from Kenya would have more biodiversity, more plants, because as we will see in next slides, her sample site is in a rural area. And then our second hypothesis was the soil samples taken from Michigan and Texas will be near open fields and structures, whereas the sample taken from Kenya will have a bigger collection of plants and wildlife. And then our third hypothesis is sample sites with more trees will have cooler surface temperatures resulting in moist soil, whereas sample sites with less trees will have hotter surface temperatures and drier soil. So we wanted to follow the soil characteristic protocols that are on the GLOBE's website, but obviously not everyone has access to all the equipment. So we did have to modify it a bit, but this was what we all were able to do. So we did follow the soil characterization protocols, but we had to modify them just a tad. So number 1, step 1 is choose a site and describe the surrounding area. By using the Globe Observer app, we looked at the land coverage and location and trees just surrounding the area. Number 2, collect the soil sample about 1 foot from the surface. And then number 3, take out any excess debris from the sample. We didn't want any grass or rocks in the sample, just so we could basically focus on the soil. Number 4, dry the soil for about 24 hours. We did this just so we could see if there were any microorganisms or anything that processed in basically 24 hours that we didn't see at the first time of sample. Number 5, analyze the soil texture, color, and possible microorganisms. And 6, relate the findings back to the specific site location. Now, this is just a map of where we all took our samples from. As I said before, I'm from Michigan. Jimena is from Colombia, but she was actually in Texas doing her soil samples. So that was really cool to see the differences. Although we're both in urban settings, we got to see the differences of the soil. And then Soraya is from Kenya, which is again in a rural area. This is our Padlet where we're first getting to know each other. So we wanted to explain where our study sites were. So Soraya, do you want to take it from here? Because you want to explain your study site?
Yeah. So in my study site, I conducted it in my home farm where there is also a restaurant. So in my home farm, it's a very rural area, not much buildings, and there's a lot of tree cover there. So I thought that would be the best place for me to conduct my research. Yasmina, you can talk about your study site.
Okay, so mine was very opposite to that. My study site was located in Dearborn Heights, Michigan, where I collected my sample at my school, which is in a very urban area where there's a lot of buildings and houses next to my school. There are very scattered trees, not that many. And then for Jimena's study site, she did hers in College Station, Texas, which just like mine is very like scattered with trees, but it's in a secluded area, and yeah.
So this is my study site. As you can see in the photographs, there was a lot of biodiversity, and the soil was dark in color. It was really moist due to the weather there. It was rainy season. It was kind of hard to dig into, but there were many different plants nearby, as I said, and there were like a lot of roots at the bottom because of all the plants that were around there. And also there was lower surface temperature due to the shadows from the plants. And as you can see here in the soil, it is like, it's very like fertile soil because of the plants that are all there. And there were many roots and everything inside there. On to you, Yasmina. Next slide. So these are some images of my study site. As you can see in the first image, there's a coconut. Oh, Amy, the other slide, please. As you can see in the first image here, there's a coconut tree, which is doing really healthy. And there's a little coconut that's just starting to like sprout. And on the other image, there's aloe vera. And right behind it, you can see some like local spinach, which is being grown there. So I would think that my soil is really fertile and it's a very good place for biodiversity. On to you, Yasmina.
So this was my soil sample, as you can see from the pictures. It was much lighter in color. It was very dry, so there was less moisture. Actually, when me and my teacher went out to dig up the sample, it was really hard to dig into because of how dry it was. I took a picture. As you can see, there's only one tree in the area, so there are very few trees and other plants nearby. Compared to Soraya's, there honestly were like no roots in the soil. And on the day of collection, it was a very hot and dry day. But other than that, our weather in Michigan is typically hot and humid. So this is Jimena's study site in Texas. As you can see from the pictures, it looks very dry as well. The grass is brown, so there wasn't as much precipitation there. Her soil is lighter in color, mostly dry, also hard to dig into. She does have more trees nearby than the site from Michigan, but other than that, it's pretty similar as to how dry it is. There are some roots from trees that are visible in her sample, and the temperatures were extremely high on the days that she took her samples, causing dry soil. Now for the climate of each study site, I'm just going to talk about Jimena's and mine. So the temperature during data collection for Jimena was 93 to 110 degrees Fahrenheit, which is 33 to 43 degrees Celsius. And then the average weather in Texas during July is 95 degrees Fahrenheit or 35 degrees Celsius. In Dearborn Heights, Michigan, it is a bit cooler. It is 78 to 82 degrees Fahrenheit on the day that I took the collection, which translates to 25 to 20 degrees Celsius. And then for the average weather, it is 84 degrees Fahrenheit or 29 degrees Celsius.
In my study site, the day I took my collection, it was 76 degrees Fahrenheit or 24 degrees Celsius, but the average temperature in July is 73 to 80 degrees Fahrenheit or 22 to 27 degrees Celsius. And the precipitation or rainfall was 56 millimeters or 2 inches.
So here are two graphs that we made, which basically shows how there's the difference in temperature and then a pretty big difference in the precipitation. In Kenya, there was a lot of precipitation the days that Soraya took her soil sample, which led to more moisture in the soil. as compared to the samples from Michigan and Texas, where it was really hot and humid, but there wasn't as much precipitation, leading to drier soil. So following our hypothesis and our research questions, here were some of the results that we found. Number one, the soil sample from Kenya is more fertile, darker in color, and in general more moist compared to the soil samples taken from Texas and Michigan. This proves that soil from rural regions, Kenya, are more rich than those in urban areas, which were the study sites Texas and Michigan. Sarai, do you want to further this?
Yeah. So the land coverage between the three sites observed are very different. In Kenya, the rural area, there is a great amount of biodiversity and the area is filled with many trees and flourishing plants. On the other hand, the sites in Michigan and Texas, both urban, were lacking in biodiversity and there were very few scattered trees surrounding the urban areas. The presence of trees creates a canopy for the soil to remain cool and moist. Meanwhile, the absence of trees allows the sun to heat up the soil, which generally increases the surface temperature, causing the soil to be drier.
Now, of course, with any science experiment, there are always limitations or changes in what your first plans are. So some of our limitations were our plans did change. At first, we were looking more into other bioindicators, but with the time that we had and the data that we got, we couldn't further that experiment. So we did have to modify it a bit. Number two, limited time and resources. Not everybody had access to all the equipment. So as I said earlier, we had to take the soil characterization protocols and modify them so that we could all have the same methodology. That way our results are more like clear and concise. And number three, a lot of rainfall, which led to spaces having water and change of area to collect data. This was more surrounded around Kenya because I know that they had more precipitation there at the time of data collection. Yeah, thank you.
Thank you.
Well done. Well done, everyone. You're getting a lot of raves in the chat right now.
Yeah, really great job. Great presentation, Yasmina and Soraya. Thank you so much.
If you have any questions for Yasmina and Soraya's project, please place them in the chat. We are going to move along since we did have to start a little bit late. But Soraya, Yasmina, again, wonderful, wonderful job. So cool. So now we will move on to the second presentation that was led by Gregory Hoffman. So we will go ahead and pass this off to Greg. And
Hi
your
everyone,
team.
so I'm Gregory Hoffman. I also work at GIO. I worked with the student 2, and so that was third Prayusha in Marwa. And so I'll go ahead and share my screen here. Get the presentation going. Oops. Can everybody see that okay?
Yes, Greg.
Okay. So yeah, like I said, it's Prayusha, third Marwa. They did a lot of really great work on this presentation. They were working really hard on it. So I'm really excited to see, gonna get to share this with everybody. So I'll go ahead and pass this off to them. And yeah, just let me know when you want the slide to be changed.
Yeah.
Yeah.
Thank you. So here's our project on the analysis on the effects of climate and location, cloud patterns and coverage. So our presentation is by Priyosho, third, and me, Marai. So next slide, please.
So In our research question, we took into account of varying regions we live in and our accessibility to certain type of research. So we decided that we would be focusing on the atmosphere with cloud protocol. So everyone in our group can collect the data despite where they live. There might be some limitation like not having a body type of water nearby. So our group decided to decide on this question of how do cloud patterns and other factors such as density, opacity, size, shape differ across the different regions of the world. Yeah, next slide, please.
So hypothesis was, after creating our research question, our hypothesis was then created. Hypothesis: warmer and dry regions such as Kenya and Thailand will have less dense, more scattered clouds, while cooler and wetter regions such as Michigan will have denser clouds with larger clusters. Also, drier and warmer areas will have clouds higher in the atmosphere, such as cirrus, while moister and cooler regions will have lower clouds, such as cumulus.
Next slide, please. Okay, so we all decided to give some background information about not just our specific site area, but also the general climate that we live in. So in comparison to other states in the US, Michigan is considered to be one of the coldest because it's really high up and has a higher latitude. So because of its cold winters and warm summers, and due to its varying season, because Michigan has 4 distinct seasons, it's considered to have a continental climate. So the DFB Köppen continental climate. In my personal experience, Michigan summers are usually very rainy and have frequent thunderstorms. When it's not rainy, temperatures can usually peak at around 100, but they never go past that. And they often stay within the 80 to 90 degree Fahrenheit range.
I'm from Mombasa, Kenya, and since Kenya is near the sea, it is mostly known for its hot summers and its shipping. I live in Mombasa, which is found in the southeast part of Kenya. In Kenya, it is mostly hot and less of rainy because Kenya is found near the equator. So the climate in Mombasa is always high and can reach up to 25 to 35 degrees Celsius.
So about my study site in Thailand, Thailand's climate is tropical for most of the country, which means the weather here is heavily influenced by seasonal monsoon wind, especially where I live in my study site, Trang, the southern part of Thailand. The temperature is about 20 to 35 degrees Celsius during winter or rainy season, and 25 to 40 degrees Celsius in summer. The observation period, like right now, is during the rainy season.
So here's just a map of the specific areas that we took our data in. So as you can see, I live in Dearborn Heights, Michigan. Priyosha lives in Mombasa, Kenya, and Third lives in Trang, Thailand. Next slide, please. So we also wanted to give an overview of the methodology and how we took data specific to each of our sites. So step 1 was to access the Globe Observer application on a cellular device. So then we selected the Clouds protocol, and at 12 p.m. Eastern time, I went outside to my backyard, which was my testing site, and then I used the Globe Observer app to take cloud measurements, and I followed the directions that it told me. So I analyzed the cloud types, the density, the size, and all the other questions it had for me. And then after that, once I wanted to analyze my data, I used the My Observation section of the app to review my pictures and analyze all my past cloud observations.
My data collection methodology was step 1. I accessed the Globe Observer app through my device Then step 2, I selected the protocol, which was clouds. And at 12 p.m. in my place, I went outside to my school field, and which was my data testing site. Step 4 was I will use the Globe Observer application, which helped me to take the cloud measurements and collect my data, which I used to find that and examine the cloud types, size, and shape, etc. My last step was to making use of my observations part of the app to review and examine the past cloud observations.
Hi. Okay. Then about my data collection plan. Step 1, I use the Globe Observer application on the mobile phone, and then I use the cloud protocol. And then the second step, just like the other member in my team, I go outside at solar noon time, use the app to take the measurement and in my study site. Then lastly, I get the data from my observation, then collect the output from there, and make the presentation.
So here's an example of one of the data that we collected. So as you can see, if you look closely at our latitude, that will be in the next slide, all our latitudes and even our longitudes greatly differ. The total cloud cover was probably the most major difference. As you can see, it was almost completely covered. It was overcast and 90 to 100% coverage. I noticed that there was some altostratus clouds and they were overcasting it and they had an opaque, they're opaque. And then I didn't really detect any mid-level clouds, so I put none for that. And then for the low-level clouds, I noticed that there was some stratus and nimbostratus, and they were broken coverage, so they were between 50 to 90% coverage. And I noticed that they were a bit more translucent than the higher up clouds. And then for sky visibility, NA, and then for sky color, you can't really see through the big overcast, so that was also non-applicable. And if you look closely, you can see some of the images that I took from the northeast, west, and southern side. So you can see the complete cloud coverage there.
In my area, my longitude and latitude had a great difference, and the total cloud cover was partly cloudy. In the high area, I found cirrus clouds. In the mid area, I found altostratus clouds, and in the low area, I found cumulus clouds. And in the sky visibility, I could see clear clouds since it was a sunny day, and the sky color is obviously light blue.
So about my result, I got the total cloud coverage like scattered around. You can see the sky quite clearly. Then I see in the high cloud, I see cirrus quite isolated and very transparent. In the middle cloud, I see also cumulus scattered, also very transparent. So and then in the low level cloud, I see the cumulus also quite scattered and pretty translucent. Then the sky visibility, you can see the sky pretty clear, and the sky color is like blue if it's not raining, of course.
So here's a graphical analysis of our results that we noticed. So if you look on the day that we collected data, for Michigan, it was 100% cloud coverage. You could not see anything through the clouds. And then in Kenya, it was between 50 and 75, so around 60% coverage. And in Tring, Thailand, it was around 25% coverage. And if you compare that to the average annual temperature of each region, you'll see that Michigan has one of the lower ones with around 50 degrees Fahrenheit. And in Mombasa, Kenya, it's around 75 to 80 degrees Fahrenheit. And then in Tring, Thailand, it's almost exactly the same with around 75 to 80. So then if we go on to the next slide. So we can apply the data that we collected from the graphs and have an analysis on it. So at the beginning of our research, we collected 2 hypotheses, and we thought that warmer and drier regions, such as Kenya and Thailand, will have less dense and more scattered clouds, while the cooler and wetter regions, such as Michigan, will have denser clouds with larger clusters. We also noted that drier and warmer regions will have clouds higher up in the atmosphere, and then moister and cooler regions will have lower clouds, such as cumulus. So because of the graphical analysis, we noticed that there was an inverse correlation between average temperature and total cloud coverage represented in the data from the areas we collected from. So we decided to note this and accept our first hypothesis. So there was a clear correlation between higher temperatures and less cloud coverage and lower temperatures and more cloud coverage. However, due to a lack of significant correlation between humidity and cloud levels, we decided to reject our second hypothesis. So the data collected showed that although there may be a slight correlation between humidity and the type of cloud, there's just not enough evidence to confidently support that claim, because some days it can differ there might be some low-lying clouds and some not. So it's hard to concretely say that. So throughout our group's experience working with and collecting data on the atmosphere, the major differences between the different areas we live in were significantly highlighted. So when you look at the climate of each area, you will see that they're vastly different, and even the cloud coverage will differ because of that. So because of the inverse correlation between average temperature and cloud coverage, we noted through the data tables and graphs, the possible connection between cloud type and cloud height and relative humidity was also interesting to note, although it might be a bit inconclusive. Next slide, please. Here are just some of the resources that we used. These just helped us analyze the climate that we live in besides our own personal experience, and it just helped us collect a bit more background. So thank you, and thank you to the GLOBE program for granting us this amazing opportunity and experience.
Thank you.
Thank you so much.
Well done, you 3. You're getting lots of praise again in the chat. I encourage y'all to check it out. So again, if you have any questions for the student group 2, please put them in the chat as we'll move on to our last but not least presentation.
Hi, my name is Zainab Zaidan. I'm from Michigan in the United States, from the North American region.
Hi, my name is Jana Kerai. I'm from Mombasa, Kenya, and I'm in the African region.
Today we will be looking at the comparison between surface temperatures and the effect of cloud coverage across 2 globe regions. Next slide, please. We can't hear the video.
Yeah, no audio on the video there.
Apologies, I have to be on mute, so let's try this again.
Hello, my name is Zainab Zaidan. I'm 17 years old. I go to school at Crestwood High School in Dearborn Heights, Michigan.
Hi, my name is Jana Kerai. I study in Sri Swaminarayan Academy, Mombasa. I'm 11 years old. I live in Mombasa, Kenya, in the continent of Africa. Hi, my name is Jana Kerai. So these are while carrying out our project, we asked ourselves these 2 questions and came up with one hypothesis. So our first question was, how does the surface temperature differ between Michigan, US, and Mombasa on the same days at the same time, solar noon? And the second question, does cloud cover affect surface temperature? And our hypothesis was the surface temperature would be cooler in Michigan in comparison to Mombasa. Over to you, Zainab. Next.
We looked at 2 different globe protocols, surface temperature and clouds. Looking at surface temperature, we collected surface temperature by using an infrared thermometer to get an exact measurement. This was important because it helped show how surface temperature and cloud coverage were related. After taking our surface temperature measurement, we took a cloud observation using the Globe Observer app. This helped us make the connection between cloud coverage and surface temperature. Next slide, please.
globe spheres. So we focused on the atmosphere. The atmospheric conditions are important because they play a role in soil formation and influence the types of plants and wildlife that can survive in a particular area. We decided to focus on the atmosphere so we can see the comparison between Michigan and Mombasa's temperatures to provide insight into what kind of plants are native to the different areas due to the weather. Next slide.
What and where did we collect? During our short research project, we collected surface temperature and cloud coverage from July 9th to 14th at solar noon. Surface temperature was measured using an infrared thermometer. Looking at the picture on the left, I took my surface temperature measurements in my backyard on my porch. Cloud coverage was recorded using the Globe Observer app, which was also taken in my backyard. Gianna's measurements were taken on her terrace at her house. The cloud coverage was recorded using the Globe Observer app and a camera, which was also taken on her terrace.
So in our graph for the 6 days, you can see that Mombasa's temperature is it's much higher than Michigan's temperature. So the 6-day average in Michigan was 26.5 degrees Celsius, and in Mombasa, Kenya was 29.9 degrees Celsius. Next.
We created a cloud timeline comparing Michigan's clouds and Mombasa's clouds. Looking at the pictures, you can see that when there were fewer clouds in the sky, the surface temperature tended to be higher, but when there was more cloud coverage, the surface temperature was lower. Next slide, please.
Interpretation of data. As shown in the graph and cloud photos, when there was more cloud coverage, the surface temperature tended to be lower than if there were less clouds in the sky. We observed that the difference in surface temperature would be even more significant if it rained earlier in the day. Next slide.
Current conclusions. So we came up with 2 questions. The first one was, how does the surface temperature differ between Michigan and Mombasa on the same days at the same time, solar noon? The surface temperature in Michigan was cooler than Mombasa on the same days of measurement and therefore had a cooler 6-day average. The second question we looked at, we asked, does cloud coverage affect surface temperature? Yes, the surface temperature tended to be higher when there was no or few clouds in the sky, and vice versa for cooler temperatures. Our hypothesis was the surface temperature would be cooler in Michigan in comparison to Mombasa. Based on our findings and observations, we accept the hypothesis that Michigan is cooler than Mombasa. Next slide. Gianna, you're on mute.
So in future projects, when we try to get these opportunities, we maybe focus on the connection to biosphere. The surface temperature and cloud cover may affect plant growth because we created a question for this. The surface temperature.
Presentación, quisiera transferir club.
I think somebody has an open mic. I'm hearing a conversation.
Yeah, Paul.
Yeah, please mute yourself. Sorry, Gianna. You can go ahead.
Okay, so we created this question: if surface temperature and cloud cover will affect plant growth and the types of plants that grow in Michigan versus Mombasa. And we also created a hypothesis for this. So the hypothesis was that plants that grow in Mombasa will differ from the plants that grow in Michigan, and the plants in Mombasa will need more water compared to Michigan. Next slide, please. Thanks for your attention. If there are any questions, please place them in the chat.
Thanks so much, ladies. I know we wished we could have done a little bit more with the plants. So, but we excited to see those next steps if we get a chance to work together again. So if there's any questions in the chat, let's see what the chat is going along. Just some really great raves. So we have about 5 minutes left. I'm going to bring up all of the students. If there's any questions that you would like to ask the students, I'm going to go ahead. We have about 5 minutes before we'll transition to our next session. So a big thank you to the students. But are there any questions? Let's see. We have one from Jamali. How could you decide if the correlation was significant or not? Did you use any analytical tools?
So this question was for us, right?
Yeah, that is for you, Zainab. Yep.
We wait, hold on. Can you repeat the question? Sorry.
Yeah, of course. So how did you know that the correlation, let me see right here, correlation was significant? Did we use any analytical tools?
Yes, we ended up using a graph to see the difference between the surface temperature and cloud coverage in Mombasa, Kenya, and Michigan.
Probably a next step, we could do some statistics, but we didn't have time for doing that. But we did look at averages, just like you said, Zainab. Allison, you have your hand raised.
Thanks, Grace. What I loved about these projects was the teamwork aspect of it and the ability to compare different regions, which is something different than some of the IVSS projects that you may have done. Were there any things that you found surprising about some of the measurements from a different location? Because I'm just curious to see what you may have learned by doing this kind of project. And it was all, I have to say, I'm just very impressed with all of the work that you've done. Thank you.
We were surprised that the surface temperature difference between Kenya and Michigan were not that far off. When we put the data into the graph, we noticed that there was only a few degrees difference in Celsius.
Interesting. Yeah, that would be really surprising, I would think.
What about the other groups?
For me, something that was most surprising was actually similar to how Zainab said. I expected the difference in cloud coverage between the areas in like Kenya and Thailand to be much more different than here in Michigan, because I know in Michigan it's almost constantly cloudy in the summer. Even outside it's like cloudy. So it was overcast for me, but it was like kind of and for areas like Kenya and Thailand, it was a little more cloudy than I would have expected, just based on like some previous research I've done on their climates and stuff.
So it's an interesting result that around the world, some conditions are more similar than we were expecting. Thank you.
Thank you.
Thanks, Allison. Larissa, I think you'll be our last question.
Sure. First, congratulations to you all. You did a fantastic job, and we're all so proud of you. What I would like to ask, how your work in Globe helps you to think about your future profession. We all hope that you will be scientists or engineers or anyone who is really taking advantage of such a fantastic experience, because Globe is really a very special place for you to grow and think about your future. So anyone who would like to address that, I would greatly appreciate it. Thank you.
I would like to say something.
Go, Soraya. Go for it.
So because of this Globe, the many competitions we've been doing, I've actually been learning to, like in the project of becoming an environmentalist, because all these globe projects, you can see how much it's infecting the environment and the plants and all the coverage there. So it would be really great if I would lean to the area of becoming an environmentalist.
Wow, wonderful. Anyone else?
I would also like to say something.
Go for it,
After joining all these competitions, I'm actually having becoming a GIO is actually eye-catching, because I've seen you can when I become a GIO, you can interact with many people, and you can also inspire them to become one. So yeah.
Wonderful, so touching. And I would like to really second Allison. We look forward for a next generation of scientists and engineers who actually treasure and have experience working together across all cultural differences. With the experience that you gain working in teams, it's really priceless. So you did a fantastic job. Thank you.
You all inspire me and give me so much hope for the future. Thank you.
Yeah, I'm actually tearing up. So thank you all so much for a wonderful opportunity and experience. It was so fun working with all of you. Just another round of applause to all these students. They did such an amazing job. But that's going to be the end of our session for today. Again, wonderful, wonderful, wonderful job, students. Such a joy working with all of you. We have our next session starting at 8:15, which is a special session on phenology. That's going to be focused on the from the Europe and Eurasia region, the European Phenology Campaign. So I encourage you all to head over there in about 15 minutes. But again, just thank you all for joining, and students, again, just you're rock stars. Well done. Oh, and I'd like to say a big thank you to all the GISN volunteers that helped out during this process. So we had 6 volunteers or 7 volunteers from across the different regions that all helped out tremendously. I will drop their names in the chat.
Yes, it was such an honor to be your mentor, and I see my colleagues online as well. I know we all. It was such a joy, and many thanks to Grace and to all a central office team for really providing us with such a great opportunity. Thank you, and congratulations to the students.
Congratulations all the students and all the GIS mentor.
All right, see you all at phenology session. That would be really wonderful. Thank you. Congratulations.